Okay, geometry students, this is section 10.6. Um, more circle stuff. So we've got more theorems on chords and secants and secant segments. We'll talk about it. Um, this can be a little confusing. I do like the vocab box here on this study guide. I know the last one for 10.5, I ended up having to cut and paste some out of your textbook because um, they gave some nice pictures to go along with the theorems of 11, 12, and 13. These give us nice pictures right along here in the study guide, so that's kind of nice. So make sure you keep the study guide handy for these formulas. So first thing in the vocab, when two chords intersect in the interior of a circle, again, by definition, they would be intersecting on an interior for chords. Each chord is divided into two segments that are called segments of a chord. So again, I'm just kind of looking at this first picture. This AE is a segment, EB is a segment, DE is a segment, EC is a segment of a chord. That's what they're talking about. So in theorem 14, segments of chords theorem, if two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So this one, again, if we kind of use some color here, EA, actually I'll keep it black, okay, that's EA, and times EB, here's my EB, equals EC, okay, that's this piece, times ED. That's this piece, okay? So the two pieces or the two segments of a chord on either side of the intersection point multiplied together equals the two lengths of the segments of the other chord, okay, multiplied together. So products are equal, okay? That's theorem 14. Now, next thing to talk about is a secant segment. A secant segment, now up until now, we have talked about a secant as kind of like a chord, only a secant keeps going through the circle. Okay, so we've always, up until this point, talked about secants being lines. Well, they can technically also be segments. They can have a start and end point, but the difference really between a secant and a chord is that secants have parts outside the circle as well. Okay, so up until now, they've been lines. So secant segment is what we're talking about here. So it says a secant segment is a segment that contains a chord of a circle and has exactly one endpoint outside the circle, okay? The part of the secant segment that is outside the circle is called an external segment. So for instance, this AE right here would be the external segment of this whole secant segment, okay? The AE would be the external part, okay? Same thing with the one below it. The EC here is the external part of this whole secant. So this is the external, okay? So it says on theorem 15, if two secant segments share the same endpoint outside the circle, in this case, that's point E, okay, out here, then the product of the lengths of one secant segment, that's the whole thing, and its external segment equals the product of the lengths of the other secant segment and its external segment. Okay, so hang with me here. So EA, we already have marked as blue. So blue times the whole EB times the whole black. Okay, so the external part times the whole thing, okay, equals EC, that's its external part, times its whole thing. I'm going to use a different color here. That's the purple. Okay, so the external times the whole thing equals the external times the whole thing. Okay? So external times whole equals external times whole. That's what they're talking about. Okay, I hope the colors kind of helped there. Theorem 16, segments of secants and tangents. Okay, now remember, a tangent, the difference between secant and tangent. Secant is going to hit the circle in 2 points. Tangent is only going to hit it at 1 point. Okay, so theorem 16, if a secant segment and a tangent segment share an endpoint outside the circle, then the product of the lengths of the secant segment and its external segment equals the square of the length of the tangent segment. Since the tangent only has one piece instead of two, that's kind of how I remember this, okay? Since the tangent has one piece instead of two, it's squared. It's like you're taking it times itself. Where this one, you're taking the external, that's the EC, times the whole thing, the ED here. Okay, I've kind of covered up the purple part. So a tangent part is squared. Okay, again, I want to point out that squared part. Okay, EA squared equals EC, the external, times the whole secant segment, ED. Okay, so the external times the whole equals the tangent squared. Okay, again, I hope the colors kind of helped there. Let's look at their example here. It says find AB and CD. So find AB and CD. Now, first of all, let's look back up here at theorem 14. You take one piece of the segment times the other part of the segment equals one piece of the other segment times its other part. Okay, so EA times EB equals EC times ED. That's theorem 14. That's what we're using here. Okay, so essentially, we are looking at this times this equals this times this. Okay, so that's what they did here. X plus 2, that was what I marked in red, times X plus 3, what I marked in purple, equals X plus 1, what I marked in black, times X plus 5, what I marked in blue. Okay. Now, the nice part about this is these X squareds end up canceling because I had one on each side. So then we end up with X equals 1. Now, it wants A, B, and CD. So then you have to use substitution. Okay. AB is X plus 1 plus X plus 3, which if we have 1 for X, that's 7. Okay. CD is X plus 1 plus X plus 5, which again, substituting 1 in for X gives me 8. Okay. All right, let's look at the back side. So solve EB, or sorry, find EB and ED. Now again, this is the whole, this is the one where you take the whole secant segment times just its external piece equals the whole secant segment times just its external piece. Okay, so remember, the whole times the external equals the whole times the external. So first of all, the whole, here's my X plus 1, it's what I have marked in red, equals the whole thing, sorry, the external, I mean marked in red, equals the whole thing. Here's the whole thing. Okay, we had to add the X plus 1 and X plus 3 together. Equals the external of the other one, that's my blue, times the whole thing of the other one. That was my purple. Again, here we are adding the X plus 2 plus 2. Okay, you do all of that. You end up with X squared plus 4, X equals plus or minus 2, just positive 2. Can't have a negative. Okay, lengths cannot be negative. So use the positive solution. Okay, and then by substitution, you can get the length of EB and the length of ED. Okay. Same thing down here in example 3, very similar. Only again, now we've got a secant segment and a tangent. So again, this part squared, okay, that's this squared, okay, equals again the whole secant segment times just the external part. So this is my x, and of course in the purple would be my x plus 9. Okay, so the external times the whole thing. So 36 equals x squared plus 9x. Now, we are going to be solving some quadratics today, okay? Most of you guys, I shouldn't say most, some of you guys, I've had in Algebra 2, and so you know how to do this, but I will go over kind of high level how to get this done. This, again, we factored. Now remember, when you factor, you're setting each of these. This is like x plus 12 equals 0, and this is x minus 3 equals 0. So that means x equals negative 12 and x equals positive 3. But again, lengths cannot be negative. So that one's taken out. Really, the only possible answer we have is a positive 3. Okay, we can't have negative lengths. So then we can substitute back in. Now, let's do some of these ourselves. Okay, here's the exercises at the backside on the bottom of your study guide. So find the values of x. Now again, here we have chord segments. Again, one side times its other side equals one side times its other side of the other one. So we've got 12 times x equals 8 times 6. Okay, so 12x equals 48, x equals 4. Hope you guys see that. It's just segment lengths. Okay. Number 2, now we're talking about secant segments. So again, we've got the external times the whole equals the external times the whole. Okay, so we got to be careful here. So external times the whole on that side would be x plus 4 equals external times the whole on the blue side there would be 2 plus 4. Okay. Now, this, remember, your x has to be distributed to each one of those. So we would have x squared plus 4x equals 2 times 6 is 12. Okay. So x squared plus 4x minus 12 equals 0. See if we can factor this sucker. Okay, if we factor here, this is going to be plus 6 minus 2. Okay, so the answer out of here is x would equal negative 6. The answer out of here is that x would equal positive 2. We cannot have a negative. Okay, so this has to be your answer, positive 2. Okay, hope everybody's okay with that. Now, over here on 3, remember, it is the tangent piece squared equals the exterior times the whole thing. Okay, so tangent piece squared equals the exterior times the whole length, which would be 5 plus 10. Okay, so now we have x squared equals 5 times 15 is 75. So now remember, when we have a perfect square equal a constant, we can take square root of each side. Okay, now typically when we take the square root, this would give us a plus or minus, right? Now keep in mind, first of all, let me keep working here. Square root of 75 would be like 25 times 3. So this gives me 5 root 3. Okay, we've already talked about simplifying square roots. So again, I don't have to worry about the minus because we're talking lengths or distances. So all I need is the positive, 5 root 3. That would be my answer. Okay, I hope that makes sense. All right, let's look at the practice A. There are quite a few problems here. Okay, practice A. First, we have to fill in the blank. So they're helping us set up our equations. Okay, then we find the value of x. So first we set them up, then we solve. Okay, so on number 1 here, we're talking about, this is that first theorem, 14. Okay, we're talking about segments of chords theorem. So we're talking about they, intersect inside the circle. So it's just one piece times its other side equals, on the other chord, one piece times its other side. So x times 3 is going to equal 5 times 9. Well, that means that 3x equals 45. So x equals 15. Okay, so you would have to fill in the blanks and solve it. That's what they're looking for. Now, I'm just going to keep going down. Number 4 here. Remember, all of this will be posted along with the answer keys, so you can kind of check yourself. This one is theorem 15. Okay, remember the external times the whole equals the external piece times the whole. Okay, that's how I kind of remember it. So 4 times, now first of all, let me point out that this x is the entire length. Okay, that x is the entire length. So it's 4 times x equals 5 times, now this whole length is going to be 5 plus 13. So this is going to be 18. I hope you guys see that. Okay, it's going to be 18. So 18 times 5 is 90. We've got 4x equals 90. So that means x equals 22.5. I'm fine with decimals here. Anyway, okay, hope you guys see that. Number 7. Now number 7 is that last theorem because we're dealing with segments of secants and tangents. Okay, so if you remember on that one, it's the tangent piece squared because there's only one piece of it, equals on the secant segment, it's the external times the whole thing. So this piece squared, that's the x squared, equals 4 times the length of the whole thing is going to be 16. Okay, I hope you guys see that. Okay, so then if we set up our equation, that is going to be x squared equals 16 times 4 is 64. Okay, and again, if we square root both sides, okay, then that's going to give us x equals, now remember, technically it's plus or minus 8, but we're only dealing with the positive because we're talking about lengths or distances. So positive 8. Okay, hope that makes sense. Okay, 10 through 24, find the value of x. So essentially, we're going to keep doing what we've been doing. We just don't have to fill in the blanks and help them set up the equations. We're on our own now. Okay, so number 10. Again, the left times the right piece equals, that's kind of how I think about it, the left times the right piece. So 6 times 10 equals 5 times x. Okay, 60 equals 5x. So x equals 12. Okay, hope that was easy enough to see. Okay, I'm going to jump down here. We've done enough of these. I'm going to jump down to 15. And as you're going to see here in a minute, 15 is going to get a little ugly. So I'm going to end up adding a page of notes here because we're going to talk about the quadratic formula. Anyway, let's first set it up. So 15, this is theorem 15. It's the segments of secants theorem. So again, it's the exterior times the whole thing equals the exterior times the whole thing. So just setting it up, here's what we have. We have x times x plus 10 equals 8 times, that's the exterior, the whole thing is 8 plus 8. Now, obviously, I could have done some of that in my head, but I wanted to write it all out so you could see it. Everybody okay with that? So, again, this x has to be distributed to both of these. So this is x squared plus 10x equals 8 times 16. 8 plus 8 is 16. 8 times 16 is 128. Now, if I pull this all over, here's what my equation looks like. And that doesn't factor, okay? 128 is divisible by 2, by 4, by 8, but none of those, when you look at all the combinations, none of those add together to give me a positive 10. So quadratic formula, okay? So let me just say, if it doesn't factor, use quadratic formula. Somehow my Q got a little weird there. Use quadratic formula. If it doesn't factor, use the quadratic formula. Now, I'm going to add a page. Okay, I'm putting a big fat arrow here so we can keep going. I'm going to add a page and we're going to work this one. So here, I'm going to go back to black here. So we have x squared plus 10x minus 128 equals 0. Now, quadratic formula. I'm going to put it in red over here. Just blast from the past here, or this may be brand new to some of you guys. Quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Okay, now this is a biggie. All right, when in doubt, and you can't factor, this is probably the next easiest way to solve a quadratic. Now you got to be wondering where the a and the b and the c come from. Okay, those are our coefficients and constants in our quadratic equation. So this is a 1 if we don't see it, right? This is a, this is b, this is c. So a equals 1, b equals 10, c equals negative 128. If there's a minus sign in front of your term, you have to keep the negative with the number. Okay, so now we have to poke that in the quadratic formula. So in the quadratic formula, we have negative 10 plus or minus the square root of 10 squared minus 4 times a times c. I need to extend that a little bit. Okay, all over 2 times a. Now, a couple of things I'm going to say here. Usually, one of these answers coming out of here is going to be positive and one of them is going to be negative. So you need to pick the positive one. In this case, since this number out here is negative, you want to pick the positive one here because this number under the radical is going to be bigger than that one to give you a positive answer. Because again, we're talking about lengths. We need a positive x. Okay, so when you solve a quadratic using the quadratic formula, you get 2 answers. That's why the plus and minus is in there. The first one's plus, the second one's got the minus in the middle. So if we poke this in a calculator, okay, I get approximately, well, first of all, let me go a couple of steps here. So this is negative 10 plus or minus square root of 100 plus 4 times 128. It's 512. All over 2. Okay. Well, negative 10 plus or minus the square root of 612 all over 2. Now, you can do the plus, you can do the minus, okay? We're going to look at both answers. So negative 10 plus square root of 612 over 2, what does that give us? So let me poke this in. Negative 10 plus square root of 612 divided by 2. And I get, okay, here's what you're going to get if you have a Casio. Negative 5 plus 3 root 17, which is great. Okay, and actually that would be exactly equals. But that as a decimal is 7.4. That's what I'm looking for. Okay, that's my answer. This one over here, if I get a negative 10 minus root 612 over 2, okay, I'm going to end up with minus 5 or negative 5 minus 3 root 17, okay? A negative 5 minus 3 root 17 is going to give me a negative 17.4. Can I have a negative answer for my x? No. So that's why we don't have to worry about that one, because we got a negative. Cannot have a negative. Okay? So all we want is the positive answer. Okay? So I hope that helped. So you may need to use the quadratic formula on a couple of these. I wanted to make sure that we went over that again. Okay? So let's go back here. So my answer down here, quadratic formula, is going to be approximately 7.4. Okay, my work again is on the next screen. So let's go to the second page. Okay. Actually, let's look at 18. Okay. So 18, this is the tangent and secant segments. Okay. Now, first thing I want to point out here is that this is marked the same as this. So both of these are the length of x, right? So it's the tangent part. So that is 8 squared equals the external times the length of the whole thing. Well, that's x plus x, or 2x, right? So this is going to give me 64 equals 2x squared. Okay, so that means that 32 equals x squared. Divide both sides by 2. Okay, so if I take the square root of both sides, remember 32 is 16 times 2. Well, the square root of 16 is 4. So that's 4 root 2. I would certainly take that, which is also approximately 5.7. Okay, I would take either one of those. I hope you guys can see that. Okay. Let's scroll down. Okay, let's look at 24. 24. Again, this is the secant segments theorem. So remember, it's external times the whole thing equals external times the whole thing. So this is x times x plus 3x equals 8 times 8 plus x plus 2. Okay, so this is x times 4x equals 8 times x plus 10. So 4x squared equals 8x plus 80. You got to distribute that 8 through. So then pull everything over. 4x squared minus 8x minus 80 equals 0. Now, divide everything, or factor out, or whatever you want to call it. Divide everything by 4. Okay? then this is just going to leave us with x squared minus 2x minus 20 equals 0. Okay, that doesn't factor, so we have to use the quadratic formula. Okay, so I'm running out of space here. Quadratic formula. Remember, this is my A, this is my B, this is my C in the quadratic formula. Okay, so quadratic formula. Negative B, well, B is already negative, so that's going to give me a positive 2 plus or minus square root of negative 2 squared minus 4 times 1 times negative 20 all over 2 times 1. Okay, now I poked that handy dandy calculator. Again, you're going to be wanting to use the plus 1 here. Okay, so that gives me approximately 5.6. Okay, I hope you're okay with that. Okay, now the last one, I'm just going to kind of steer you in the right direction here. This last little bit. This would be back to theorem 11, the segments of chords theorem. But one thing I want to point out is if we have a diameter that goes through another chord, we know it's a diameter because it goes through the center, okay? That means that this is the same as that. That means it bisects the chord. If it is 90 degrees to the chord, then it bisects the chord. Okay, so if a diameter, that was one we learned, I don't know, 10.3 maybe. If a diameter is perpendicular to another chord, then it bisects the chord. So I want to point that out. So like on this first one, it says find the length of AB. Well, the length of AB, they say off to the side there is 50 centimeters. Okay, find the length of AC and AD. Well, they tell you up above that the length of CD is 160. So that means AC has to be 80. And that means AD also has to be 80. Okay, because again, those have to be congruent. Okay, I'll stop there. You all can finish. Okay, this concludes section 10.6.